Hello, I'm Jennifer McClendon, Education Manager for Sportsfield Management Association. Thank you for attending our post-conference webinar education series. Today, our speaker will be Geoff Rinehart. Geoff Rinehart has 22 years experience in the turf grass and landscape industry, working in various parts of the country. He earned his bachelor's degree in turf grass management and landscape contracting from Virginia Tech and a Master of Science in turf grass science at Michigan State University. After graduating from Michigan State, Geoff spent 5.5 years as a research technician conducting turfgrass science research at Washington State University and spent 4 years coordinating the Tacoma-Pierce County Natural Yard Care Program, conducting outreach and education for homeowners and professionals in Pierce County, Washington. From 2013 to 2018, Geoff served as coordinator of the Arboretum's Grassroots Initiative, which includes a 1.3-acre interactive turfgrass exhibit, a website, and ongoing homeowner lawn maintenance workshops in the spring and fall. His experience has also included working on golf courses in the landscape industry in Maryland, Colorado, Washington State, and Hawaii. Geoff joined the University of Maryland as a lecturer in the Institute of Applied Agriculture in July 2017, teaching courses in landscape and turfgrass management. Today, Geoff will be presenting Managing Common Insect Pests in Cool Season Athletic Fields. Geoff?
Thank you, Jennifer, for that introduction, and thank you to SFMA for inviting me to present this webinar today. It's a great way to kind of finish out the post-conference webinar series. And let's see. I have a little trouble advancing here. Jennifer and I were testing this out just a little while ago, and now I'm having trouble with this. Let's see.
Sometimes it freezes up.
Yeah,
I've done it before, and it takes a second.
Frozen. Okay, maybe I hit too many buttons at once. So again, thank you so much for the invitation today. I really appreciate it. Obviously we've been dealing with turfgrass pests since, turfgrass management has kind of been in existence, and couple article clips from the USGA green section from earlier on in the 20th century talking about fighting June beetles with caddies, and the fact that caddies, there was a bounty of 50 cents per 100 of the captured June beetles. So just kind of interesting to see this. And then looking at brown patch, we're not going to talk about diseases today, but certainly we deal with brown patch in a large part of the country still today. So, what's old is new, and we're still talking about these pests here. So when we think about what a turfgrass pest is, this is really an organism that causes a measurable deterioration in the aesthetic or functional value of turf. And so obviously for turf, we're more worried about, certainly for athletic field, for a safety aspect, that's the number one parameter that we're concerned about. And then secondarily, certain aesthetic aspect as well. And so we're not worried about yield per se, but we're more concerned about that safety aspect and aesthetic aspect and functionality aspect of our turfgrass sports fields. And so when we think about our three primary categories of turfgrass pests, I'm going to obviously talk about insect pests today, but I wanted to kind of present this in the broader view of integrated pest management. Obviously, we have a category of weeds. This would be a plant out of place and consists of broadleaf weeds, whether they be perennials or annuals. We can also have annual or perennial grassy weeds. And then if we think about diseases, this would be a biotic organism called a pathogen that causes a decline in another organism. And today we're going to talk about insect pests. And I really kind of focused in on the top 6 or 7 insect pests of cool season fields, because once you get into warm season grasses, you've got another array of pests, and some of those overlap, but we'll concentrate today on cool season turf fields. And it's important to remember with insects that the vast majority of our insects really have no effect on the turf. and some can be beneficial predators. So these beneficial predators are preying on some of the species that we consider as pests. So, and there's a relatively few that are feeding on our grassroots stems and leaves in the grand scheme of things. And to kind of uh, extrapolate on these beneficials, we can kind of categorize them into either being a generalist or a specialist. So again, these beneficial insects will feed on insects that we consider pests. A generalist predator would be one that feeds on a variety of different pests, different species, different insect species. Sometimes you can have a specific arrangement between species, and so this would be more referred to as a specialist. When we're looking at categorizing these beneficial insects, that's one way of doing that. So some of our beneficial insects in cool season fields include things like ground beetles. I've given the kind of the scientific family name to the right here in parentheses, but ground beetles, lady beetles or ladybugs, lacewings, flower flies, sometimes called syrphid flies, and then we also have big-eyed bugs. Ants, believe it or not, are oftentimes beneficial insects. Know that in sandy soils, they can sometimes form mounds, and so that's a little bit of a disruptor, from that uniform surface. But a lot of ants are very good beneficial insects. And then we have things like damsel bugs, various plant bugs could be beneficial as well, and then spiders and predatory mites. So we've got a lot of beneficial insects within the environment that if we are able to kind of harness their and leverage their natural tendencies, we can use that to our advantage in managing turfgrass insect pests. So when we think about this concept of integrated pest management, one way to look at it is the selection, integration, and implementation of pest control based on predicted economic, ecological, and sociological consequences. So obviously, those of you who manage fields and a lot of public fields know that we're part of the broader environment. We certainly have a community that is stakeholders on our fields, and so we're not looking just on that the economic consequence, but also being cognizant of the environment around us and our stakeholders as well. That refers to the sociological aspect of this. A little bit more specific definition would be one where we have a system of controlling pests in which pests are identified, action thresholds are considered, all possible control options are evaluated, and then selected controls are implemented which have the least adverse effect to the environment. So this is basically speaking to using a variety of tools, variety of techniques and approaches to this integrated pest management, whether this be insects, weeds, or diseases. And so we'll kind of talk about each of these as we kind of go along and talk about managing insects within this context of IPM. So when we think about our turfgrass cultural practices, there are 5 primary cultural practices. I've added one more to the top here, but if you read a classic turfgrass textbook, we'll talk about the cultural practices of mowing, watering or irrigation, fertilizing. They'll talk about cultivation. So I've kind of put aerating and thatching in there for cultivation. Those are the 2 most common practices that we see with cultivation. And then pest management. So I've also added in here variety selection because as I spoke in my last webinar, proper species and variety selection for the site based upon the desired function of that site is so critical. So if we start out with good, high quality plant material, high quality varieties, and we have the species that is best suited for that particular field, then we greatly improve our chances of that field being successful and really kind of reducing the stresses as much as we can on that field in combination with proper cultural practices. So the idea here is that if we can conduct each of these 5 things above correctly, we spend less time on pest management. And of course, that makes our jobs easier if we can spend less time on pest management. Everybody has enough going on to maintain their turf grass and recreational facilities. That if we can reduce the uh, the need for pest management, that's helpful. And so we think about this concept of a pyramid of IPM tactics, where we build our program based on cultural practices, which I just mentioned in the last slide. So that's, proper site preparation, proper plant selection. But we also look at things like physical or mechanical control. Now, all of these may not be always applicable to every pest that we have. And certainly we get into more physical and mechanical controls when we get into some of our landscape ornamental pests. But that's an aspect of IPM. And then we look at biological control. So what I just spoke about 3 or 4 slides ago, with consideration to our beneficial predators, there's also beneficial nematodes. All these can be, harnessed within a system of managing insects that helps us as the manager to kind of reduce the potential damage caused by some of our pest insects. Going up the pyramid, we look at our chemical use as kind of a last resort, trying to find, biorational pesticides, things like soaps, oils, that might work. Obviously, some of those are a little bit more geared towards the landscape ornamentals, but the concept is still sound. And then, we're going through all of those steps before we're using our conventional, traditional pesticide products. And so for our integrated pest management, we're looking at identifying the pest. It's really important to know what the pest is. If you know what the pest is and learn the life cycles of the different pests that are common in your area, this really helps to provide a framework for management of that pest. As I mentioned before, threshold levels are very important as well. Just because you might see 1 or 2 insects doesn't mean that poses a real threat of damage to that turf. So we look at, what population would we start to see damage? And certainly we want to take action a little bit before that, but we don't need to take damage. We don't need to take action way before that. So being able to monitor and know those threshold levels is very important to the IPM process. Thirdly, we want to be able to monitor for the pest. So knowing what time of year that pest is present and in what growth stage that pest is present during different times of the year is very helpful to lead into our monitoring. I mentioned cultural control, mechanical control, and using less toxic products. The other part of that too with pesticide use is if we can make a spot treatment or a regional treatment to an area that's being affected, there's no need to apply to areas that aren't as susceptible or aren't as affected. So trying to pinpoint the use of our products is an important part of IPM. If you haven't developed an IPM program or written IPM plan, it's an example of one that I found just as kind of as a screenshot here, but I certainly encourage you to develop an IPM plan as there's increased scrutiny on our maintenance practices in a number of places across the country. It's important to to be able to recognize that if you're able to write out your IPM plan, this improves your um, can improve your communication with stakeholders um, within that realm, and really also be used to train new employees. So there's a number of different reasons for having a written IPM plan. And this is one of the best management practices that's mentioned within the SFMA best management BMPs as well. So when we look at our turf feeding insects, I put a couple of these cool season insect pests on this particular image. And so we think about chinch bug. We'll talk about chinch bug. We'll talk about billbugs. Here's the adult. Here's the larva or the juveniles. Cutworm, I didn't have a picture for, but I put them down towards the base of the plant there at the crown, just above the crown. Grubs we see in the soil, typically in their juvenile form. Of course, the adult beetles will be flying around in our landscapes. Sod webworms, so these are going to be above ground surface feeders. And then we have European crane fly that might feed on the roots or the shoots, so above or below the ground level. So the point that I will cover this in a little bit more detail, but it's important to think about where different insects are located within that turf grass system. So that can help us kind of pinpoint our scouting efforts. So if we look at this, we know that grubs, again, these are juveniles of beetles within the scarab family in the beetle order. These are root feeders, so this would be an example of grubs here. Billbugs, they're going to basically feed on the lower part of the stem, can get in the roots a little bit. Chinch bugs are going to be feeding on the leaves and the stems, so we're talking about up in here. If we look at the profile here between the verdure or the green part of the plant into the lower part of the stem and then into the thatch and the soil proper. So this is kind of, we think about this as our side view of our turf grass soil matrix here. And it's important to know where these different pests might be located within that profile. For sod webworms, these are going to chew grass blades off and pull into tunnels. So they're feeding on the lower part of the stem, and then the tunnels will be just around that thatch area. Cutworms are going to feed on grass leaves and clip the grass right above the crown. As I mentioned before, European crane flies are going to feed on shoots, crowns, and roots, and then armyworms feed on leaves. So know that we had a armyworm outbreak in a lot of our northern areas about 2 years ago, and that was one that we don't usually see in that type of volume in a lot of the northern part of the transition zone and the northern region of the country. Of course, the folks managing fields down in the south, southeast are commonly seeing armyworms during the summer, especially the last part of the summer, but not something we deal with too often on a regular basis in the northern tier of the country. So to summarize, we've got our surface feeding insect pests are going to be our sod webworms, our chinch bugs, our billbugs, cutworms, and armyworms. And then the root feeding pests are generally going to consist of the white grubs. And then our crane flies, know that we have some crane fly issues sporadically in the Northeast and into the Midwest, as well as the Pacific Northwest. These have the capacity to feed on all parts of the plant. And so why is it important to realize whether something is a surface feeder or a root feeder? Well, there's a fungi group called endophytes. One of the common endophytes is Neotyphodium, and this produces a symbiotic relationship with the plant where this fungus will grow through kind of in between plant cells and be transmitted also via seed And basically, this fungus renders the plant unpalatable to surface feeding insects. And so when we're thinking about variety selection and cultural control practices, this is a great way to ward off surface feeding insects without the use of pesticides, just the natural inherent nature of this symbiotic relationship, making that leaf unpalatable to those surface feeding insects. This is a bit of an older slide. This is from an NTAP National Turfgrass Evaluation Program trial when endophytes were first coming onto the scene a few decades ago. And so you saw this particular variety was devastated, did not have any endophyte. This one, not in awesome shape, but in pretty good shape. And this one had the endophyte. So lots of research that shows that, those that have an endophyte are a lot more resistant against surface feeding insects. Now remember that surface feeding insects. So grubs are not really affected by the endophyte since they're a root feeding insect. And so these endophytes are growing intercellularly and concentrated within the leaf sheath and the seed of the plant. And they are within some varieties of perennial ryegrass, tall fescue, and fine fescues. So sometimes these endophytes will, if you let seeds sit for a few years, these will kind of lose their potency within that seed, but they are transmitted via seed. A lot of times it's tough to know without testing resource whether or not certain variety contains the endophyte, but typically your professional distributors will have an idea on which varieties within these ryegrasses or tall fescues that have endophytes within them. And so again, seeking varieties that have endophytes will help in an integrated pest management plan to try to ward off these surface feeding insects. So again, controlling surface feeding insects, and basically they're producing these allelochemicals, basically rendering that leaf unpalatable to the insect. Okay, so we're kind of marching through here with the IPM steps. Talked about a lot of these, and then obviously record keeping is an important part to that kind of closes that loop. So record keeping is very important, not only for pesticide use requirements with your state Department of Ag, but also to keep track of what worked, what didn't work, what might have worked in certain situations, what some of your approaches have been. So very helpful to keep records on what you're doing and an important part of the IPM process. So when we think about identifying the target pests, a good example of this would be with the grub complex. So with the grubs, again, these are C-shaped juveniles of beetles. So you see this within the grubs. You're going to have raster patterns. So these rasters are a pattern of hairs on their backside. I'll kind of contrast this with I'll contrast this with billbugs over here on the right. So the grubs will have, I don't have the picture of this, but the grubs will have 6 legs. Billbugs, although similar shape, will not have any legs. They'll be legless. So way to kind of tell billbugs apart from grubs there. But if we've got a grub, we can identify it to the species based upon this raster or hair pattern on the backside. So this particular image was from Ohio State, and Ohio State's got a lot of good information on raster pattern, a lot of good pictures. But if you see these raster patterns, that's a good way to be able to make distinctions among the different grub pests. So with our grub thresholds, typically this is somewhere between 6 to 10 grubs per square foot. So you see these C-shaped cream-colored grubs here within the soil. And so typically if we're less than that, if we're at that or less than that, and we've got good fertility and a good fertilizer program, then we typically do not need to apply an insecticide in that situation. If we're above that threshold, we still can consider, kind of, what our fertility program is and do we have an otherwise healthy stand of grass, but we might consider applying a product to control those grubs. So if we're less than that, the grass should be able to survive and do pretty well with less than that population. So talk about threshold levels and then also the time of year. So with the grubs, we're looking at doing the sampling in spring or in fall, and we'll talk about that grub life cycle here in a little bit. So being able to implement a monitoring program is important. So obviously having some history with your property and knowing what pests you might be most on the lookout for is very helpful. So this kind of ties back into record keeping and note keeping from years past. One way to be able to bring insects to the surface, and this accounts for grubs, for sod webworms, billbugs that might be lower in the crown area, chinch bugs, would be to put a few ounces of soap into a few gallons of water and then pour that soapy water solution onto the turf. This basically irritates insects that are either in the soil or very low in the crown area and brings them to the surface so that you can get a gauge on what the insect pest population is for that particular area. One way to monitor adult billbugs is by a pitfall trap. And this pitfall trap here, basically you've got a funnel, kind of a cutout cup here. And so this is buried at soil at the ground level. As the insect crawls across, they fall into this pitfall trap and they're unable to escape from it. You can also make a pitfall trap out of PVC by cutting and opening in the top of that PVC. In this case, they put it across this area and then they've angled that PVC down into kind of a central collection device there. So you'll see here, this happens to be a billbug, and these billbugs are surface feeders. The adults will crawl along the ground. So as they're crawling along the ground, this is a pretty effective trap for being able to catch them as they fall into it. So gives you an idea of activity in your property. For grubs, again, these C-shaped cream-colored grubs that are juveniles of beetles, we're typically kind of cutting out a 1 square foot section in a couple different places, and then being able to count those grubs. Again, 6 to 10 grubs per square foot is our typical threshold in a lot of our transitional or northern areas. The grub damage kind of looks like this. Is kind of this irregular pattern that looks a little droughty. And it makes sense because if you had a situation where roots were compromised, not able to take up water, the symptom would be that of this drought. So when you've got a lot of times these droughty symptoms can be tough to diagnose, but a lot of times insect damage will be in somewhat of a more irregular pattern than straight up drought stress. Okay, I talked about the endophytes. Some of the research looking at endophytes was done by my predecessor, Dr. Kevin Mathias. And what he did is he had nutrient solution in little Dixie cups with ryegrass, and he placed chinch bugs in these cups and looked at survival rates and the grasses that did not have endophytes and those that did have endophytes. And so, in the endophyte infected ones, the population of chinch bugs eventually went down after, a week and change plus or minus there, while the endophyte free plants did not see much change in population. And so why did the population decrease in these endophyte infected plants? Well, because if you don't eat, eventually you're going to die as an organism. So it's not that they were killed from anything else. It's just that it was so unpalatable, they didn't want to eat, and eventually they died. So this was some of the research that was done looking at endophyte enhanced resistance in turf grasses a few decades ago. And it's still pertinent for today. Gosh. Sorry. As I try to move to the next slide here. Again, I'll just remind people that these endophytes are within not all, but some cultivars of ryegrass, tall fescue, and fine fescue. And so it's important to talk to your seed distributor about identifying varieties that contain these endophytes. Sorry, I'm locked up again here with this computer. Okay. So, think about, selecting the appropriate control approach. Obviously, think about biorationals and less toxic products, less toxic product options. We have a lot more options for these now than we did even 5, 10, especially 15 years ago. So I certainly encourage people to think about using some of our biorationals and less toxic products. So, especially if you're right at the threshold where you don't necessarily need to get 90 or 100% control of a population and knock that population back below the threshold. A lot of these products are going to be a lot kinder to our beneficial predators compared to some of the products that are broad spectrum. And so there'll be oftentimes be a lot more pinpointed to be able to have a control aspect to the pest, but also preserve predators, beneficial predators. So again, talking about these white grub raster patterns. For the example, for the Japanese beetle, you can go through here and find that the hair pattern of the raster pattern is kind of a V shape here with this. With the green June beetle, this is a little bit bigger grub, but you see kind of the zipper pattern. Very similar with the May June beetle, kind of that zipper pattern with the rasters. And then if you look at the mass chafer, there's actually no pattern. So the fact that there's no raster pattern, no discernible pattern, is good information too. So, being able to use these resources, learn your raster patterns to be able to identify what grub species you may have is an important part of managing your insect pests. So there's some diagrams there. But being able to learn this is an important aspect of this. So I'll go in and talk about 6 or 7 of our primary pest species within cool season fields. The first of which is the Japanese beetle, and this was introduced into New Jersey via nursery stock back in the 19 teens. Typically, we find this largely east of the Mississippi, maybe a little bit west of Mississippi, but for the most part, the eastern half of the country. And this is one of our more common scarab pests that we find, not only in the turf, but also in ornamentals. We know that the adults are going to feed on a lot of our ornamental plants, particularly those in the rose family within our landscapes. And so, we find, again, the rose family are going to be the preferred plant for those adults. And then the grubs, the juveniles, will feed on turf grass roots. So in the landscape, we find that we see this what's called a skeletonization type damage. So they'll feed on the fleshy part of the leaf and then leave the harder to digest veins. But these guys are up to about 1/2 inch in length. They've got a metallic sheen to them. The head and the pronotum's this region right behind the head, are green, and then the wings are copper, and you'll see these white tufts of hair protruding from the sides of the abdomen. So we think about our insect regions. You've got the head, the thorax, and then the abdomen. At head, thorax, and abdomen at the very end there. So the adult feeding is from late June through August. Larval feeding is going to cause root damage. And our larval feeding period is from mid-August to October. And this is where it's most likely to be most noticeable. And this also occurs in the spring from mid-April to late May. So the reason that this is more likely to cause damage in late summer and into mid-fall is because our cool season grasses have been going through a stressful period through the summer for the most part. So you see roots start to decline through the stressful part of the summer. Roots are still growing, but there's more that are dying than growing. So you see this natural root decline in cool season grasses through the summer. And so they've already got a little bit of a stressful root situation. And if you add in insect feeding to that, you're most likely, if you do have damage, you're most likely to see that from late summer into early fall. During the springtime, the third larval instars are also present, but in the springtime, you typically don't have a lot of stress on those plants, and so the plants are able to be more robust in their tolerance for grub feeding. So I think I showed you this, looking at this, peeling back the turf, digging up a square foot section and being able to look for these grubs. The other thing that we'll see with grub damage is this kind of these drought symptoms in grub infested lawn. So in this situation, you had tire tracks that, from the pressure of the tires, from the wear and tear, the wear traffic of the tires, led to a decline in the turf grass quality there. But if you think about it, if they're feeding on roots, what type of symptom are you going to see? It's going to be more of a drought-like symptom, because that's compromised the plant's ability to uptake water. So the other thing too with insects is that a lot of times there'll be kind of a irregular pattern to the damage that we see. With many of our diseases, there's a pretty common radial pattern that's somewhat consistent. But with insect damage, a lot of times you'll see kind of an inconsistent, irregular field pattern. So I mentioned these thresholds, about 6 to 10 per square foot. They'll reach up to length and up to 1 inch in length for the grub, and the Japanese beetle has a V-shaped raster pattern on its backside. So the Japanese beetle life stages include hatching from an egg and then going through 3 larval instars. So these larval instars are are juvenile stages. It will go through a pupation stage and then emerge as a totally different looking organism as an adult. So this is what we call a complete metamorphosis, where that insect goes through several larval stages and looks completely different as an adult. And so you notice obviously that it gets bigger as it goes along. This is a very good picture of C shape, cream colored, and then 6 legs, 3 pairs of legs for this particular Japanese beetle. And this is going to be kind of something we can relate to. All grubs are going to look similar to this. We contrasted that with the billbug larvae, which were kind of plump shaped, a little bit of a C shape to them, but they did not have legs. So the scarabs are going to have 3 pairs of legs in this juvenile form there. So they'll undergo 1 generation per year. They will overwinter as a third instar within the soil, and then they'll go into pupation in late May. The adults will emerge as we get into mid to late June, and this continues into August. Obviously, mating occurs with the adults, and then the females will deposit eggs in the soil. And it's important to remember that those eggs need moisture. So if we're able to keep the turf on the dry side as we get into July and August and make sure that we're not overwatering, we can actually kind of lend to more kind of natural mortality of those eggs in a drier situation. So that gets back to some of the cultural practices that I talked about earlier on. So that cultural practice of irrigation and watering, again, if we can kind of reduce that, if possible, that will help. The drier conditions will help reduce the egg viability of Japanese beetles. So if we look at the Japanese beetle annual life cycle, and I'll hold this up as basically what happens for chafers, for oriental beetles, for all of those annual grubs. This is what happens with this life cycle: is that you are in an overwintering stage, obviously through the winter. As the soils warm up, that grub will move towards the root zone and begin feeding in that root zone. At this point, it is a third instar larva, and then it will go into pupation as we get into the second half of spring, emerge as an adult in June, depending on temperatures and where you are in the country, and then obviously as an adult, kind of feed on our landscape plants, particularly our rose family plants. And then we'll mate, lay eggs as we get into the second part of July. And then those eggs will hatch into larvae, which go through a first larval instage, a second larval instage, and then eventually, as they get bigger, what's going to happen? They're going to feed more, just like anything. It's bigger, it's going to feed, it's going to need more food. So this August into September is when we see the greatest propensity for damage, because again, the cool season grasses have come through a stressful part of the year. In the summertime, root system is probably compromised already from the environmental growing conditions of the heat, and and having insect feeding there kind of might do them in even worse. So again, based upon those threshold levels, it's important to monitor, especially if you have had grub problems in the past. So just looking at some studies on the influence of soil moisture. So if that turf is irrigated, those Japanese beetle eggs have, and really scarab eggs in general, are going to have a greater propensity to survive. And so what can we do from a cultural perspective, things that we can do to manage our grass? Well, we're trying to we know that healthier plants are going to be able to stand a higher population of threshold grubs. So we want to do what we can to increase root root growth. So that's proper fertilization techniques in the fall. And obviously the spring, we want to emphasize for cool season grasses. We certainly want to emphasize fall fertilization, but we want to be able to provide the plant with what it needs through the spring and the growing season as well to be able to recover from foot traffic and from play. From an irrigation management perspective, we know that the beetles like to lay eggs in moist soil conditions. So if we can try to back off on the irrigation a little bit in August, late August and September, we shouldn't need to water as much as we had been watering during the height of summer. These dry conditions can lead to desiccation of the grub eggs. So from a preventative versus curative perspective, we've got several products that can be used as preventative that you see there, and then Dialox or 7 for a curative treatment. So when do you put out a preventative? Well, I would suggest that your decision to put out a preventative may be based on a few things. It should be based on scouting. So do some scouting in the springtime and see if you see those third instar grubs. If you don't see those, then or they're very low population levels, you probably don't need to apply anything. So the other thing to think about too is that you really want to be on top of your monitoring if you've had grub problems in the past. Grubs, like a lot of insects, are kind of within a given community kind of patchy. So you might have them on one part of your property and not another part of the property. You might not have them at all, and somebody down the road has them at their facility. So if you haven't done scouting, I definitely encourage you to do some scouting this spring to gauge, what is your grub population on different parts of your property. And so again, a lot of times, these are low levels and really don't require any action besides monitoring and adherence to proper cultural practices. This is a graphic from Purdue, kind of showing, it's a little bit old, but it shows, of course, we don't have Mach 2 on the market, haven't had it for a number of years, but it shows the relative level of control based on efficacy at different times of the year. So we see our things like Merit and Arena applying these early on. They're going to yield a good to excellent results through the summer. These are systemically translocated through the plant, so they'll move into the plant and then stay in the plant for several months, feeding on that plant, basically killing insects that feed on that plant. And then the anthranilic diamides, a good example of which is a celleprin. This is chlorantraniliprole. Another example would be cyantraniliprole, which is ferrants. So these are don't have the pollinator impact concerns that the neonicotinoids have, and so they are effective when applied early in the season. So we're looking at a spring application, and typically these products will provide control for 3 to 4 months through that summer growing season. So acelepryn and ferrants, again, are two examples, two different anthranilic diamides that are available. So not to discount the importance of predation and parasitism. So defants are a consumer of white grub eggs, so they can help to reduce populations. And then there's something called a Typhia wasp that is a parasite, a parasitoid, and basically helps to control grub eggs as well. So these Typhia wasps are an important part of natural control for these. Just a note on acelepryn or chlorantraniliprole, this is labeled for early and early control here in the springtime, and then kind of mid-season control This gets out in June or July. This is certainly not a rescue treatment. But as I mentioned, like grubs, if you have cutworms, if you have sod webworms, we saw this be effective against armyworms a few years ago when we had the fall armyworm outbreak. So this is a good product for a number of different insects. And if you have had those issues in the past, or if you're scouting and you see issues in the spring, you can put this out in the springtime. So that earlier application is going to be a lot more effective. Another product that is organic product is Bacillus thuringiensis variety Galleriae. For those of you who might have experience
Oh, Jeff, are you still with us? Give him a minute to get back on.
Okay, sorry about that.
Let me make you co-host. Okay.
Oops, hold on. Let me get to. Okay, so talking about, sorry about that. Talking about organic product called Bacillus thuringiensis variety Galleriae, and this is called grub gone. For those of you who have experience with landscape ornamentals, you might be familiar with Bacillus thuringiensis variety Kerstaki as a control for caterpillars. This is variety Galleriae that's used for control of Japanese beetles and mass chafers in the first instar stage. So pretty good control, 70 to 80%. This product is a little bit pricey, but if you're in a situation where you're using organic products, this is one product that can be used pretty effectively for grub control, again, in that really early kind of first instar stage. So we're kind of thinking this would be a product you'd put down in late June or really early July in a lot of areas of the country. So just a little bit of a data table here, looking at grub gone compared to Meridian, which is a neonicotinoid. So really within the study, looking at statistically the same type of control, you know, up in the 70s and 80s percent wise, not quite in the 90s, but you know, if you're just trying to knock the population back to knock the population back below threshold levels, then 70 or 80% control might work just fine. Okay, so moving out of grubs, I want to talk a little bit about cutworms. So we've got different cutworms through the country. One of the more common ones is the black cutworm. This University of Nebraska publication is very good at kind of bringing in some of the details of distinguishing between the black cutworm, the bronze cutworm, and then the variegated cutworm. Black cutworm paired spots that are uneven in size, kind of this greasy appearance. And so again, the black cutworm is going to be more common in a lot of our places with cool season grasses. And basically, this is a caterpillar. The moth, the adult moth, is seen there in the upper right, about 1.5 inches in wingspan. Kind of this gray moth with black, we'll call it black dagger moth, dagger markings on that front wing. So this is a pretty key characteristic of our cutworm adults. And then the larvae are going to be 1.5 to 2 inches in that last larval instar. Just wanted to contrast that with fall armyworm. So again, a few years ago, we had a pretty noted fall armyworm outbreak that was, a lot of people said, had been the worst in the northern regions in decades. So this is something we don't typically see in the northern regions of our country. But with this, the big identification here with the fall armyworm was the Y marking, the upside down Y marking on that head capsule there, was a big part of that. And then you've got these stripes along the proleg, what's called the prolegs there. So that was a fall armyworm, but that Y marking on the head capsule was a big identifier. And so within the transition zone, the black cutworm will overwinter as a pupa. So if the soil temperatures are pretty cold, that winter mortality is high. So it's kind of, black cutworms kind of marginally hardy to overwinter here in the transition zone where I am in Maryland, and even less so as you go further north. So how do we get these cutworms? Well, they overwinter down south a lot better, and then they will kind of move their way northward based on the prevailing summer winds from the south. So there can be up to 3 generations. The larvae will be active starting about 1 to 2 weeks after peak flight activity. So if you're starting to see those adult moths with the dagger markings flying around, you know that the larvae will, have some activity about a week or two after that peak flight activity. So what do? They will lay their eggs on grass stems here. So this is pretty distinctive here with those eggs on the leaves. Again, they'll blow from the south into the north via storms and strong wind patterns. Typically can't survive in the north, but females can lay several hundred eggs on the leaves and the leaf tips of grasses and other host plants. Also want to talk about sod webworms. These are sometimes known as grass moths or snout moths or grass moths. So you can kind of see the snout here, very distinguishing feature of these adults with that snout. They're pale brown to whitish to dull gray. And so this color is a pretty drab color. Wingspan will be about 3/4 to 1 inch. And these will overwinter as mature larvae within silken tunnels. So if you're doing a little bit of monitoring and you see these silken tunnels, that's a good indication you may be dealing with sod webworm. The larvae will feed in spring, and then they'll pupate in late May and early June, and then those adults will kind of fly in a zigzag pattern over the turf at dusk. And then the females will fly, lay their eggs in June, early July. That first generation of larvae will feed from July through early August, then pupate and then become adults into late July. And then the second generation we see as we get into the last part of summer. So typically these are 2 generations per year. So here's what they look like. Again, a little bit nondescript there. Most of their feeding occurs at night. They will produce these silken webs and what we call frass pellets. So they'll chew on the leaves and then excrete that, creating these frass pellets. And these typically turf can withstand about 10 to 15 per square yard of these when you're doing your scouting and evaluating threshold levels. So we think about the fact that these are both surface feeders, and both sod webworms and black cutworms are surface feeders. So endophytic turf grasses will have a large amount of resistance to these. There's also natural control due to predation and parasitism. And some of our safer products include things like azadirachtin, Bt Krustaki, and then there's beneficial nematodes as well. Conserve, which is spinosad, are going to be more effective. All these biorational products are going to be more effective on earlier instars than they will be on larger instars. Oh, I hit something to yeah, get me out of the. Okay, so I know we're coming up on time here, Jennifer, but I want to try to mention one or two more others here. So chinch bugs there's 4 different species of chinch bugs through the country. Typically, we're dealing with hairy chinch bug, um, sometimes down south, southern chinch bug, buffalo grass, chinch bug in areas where buffalo grass, but typically in the northern regions, we're dealing with hairy chinch bug on a lot of our cool season grasses in the northern part of the country. So these chinch bugs undergo, from an egg, they'll undergo 5 nymphal instars. And so they will go through an incomplete metamorphosis. So you'll see that the later nymphal instars will progressively look more like an adult. So this is what your adult looks like. So contrast that with the grub, where you go through a complete metamorphosis, where the juvenile looks completely different than the adult. Instead, these hairy chinch bugs look progressively similar to an adult as they go through their growth stages. So these are going to vary in, from about 1 to 3 millimeters. As they get bigger, the adults are going to be 3 to 4 millimeters, kind of black hairy. They'll have, there are some that have more prominent wings, some that don't. If there's food in the area where they are, then they will be short-winged. If there's not much food in that area, then they will kind of develop better wings and be able to fly to areas to look for food. So kind of an interesting aspect for chinch bugs here. But they'll this is what they look like uh, with with that kind of black to white wings with black markings there. Okay. So a lot of times the legs will have kind of an orange tint to them. You see the short winged and long winged forms there. And then for the life history, they will undergo 2 generations per year. They'll overwinter as adults in thatch or heavily mulched areas for protection. And then they'll have 2 generations during the growing season. They'll become active in the spring as temperatures reach 70 degrees. And then the adults will mate over a 2-week period. Egg laying occurs from early May to early June. And then they'll have 5 nymphal instars from June to July for that first generation before that. Once that first generation becomes adults, then they'll undergo a second generation. And as we get into late summer, so then the adults will move from that second generation, they'll move to overwintering sites in late fall. And so this is what the damage looks like. Like a lot of our insect damage, it's kind of this irregular pattern. You see this unthriftiness. They will feed on the lower leaf sheath and inject toxic salivary glands into the plant. They'll have kind of these circular to irregular brown areas. A lot of times they'll be kind of reminiscent of drought type symptoms. That's what the threshold is. That's what the chinch bugs damage looks like. And because they're really small, we can withstand more of these per square foot. So typically 15 to 20 per square foot. You would do this monitoring with a soapy water flush to bring them to the surface, kind of irritate them and bring them up to the surface. So these are good examples of what chinch bug damage looks like. You'll see with this irregular pattern. Here you've got really healthy grass and right next to pretty dead grass right there. And so it's pretty typical of our chinch bug stand symptoms. So host plants can be on a variety of different plants. course, our ryegrasses and fescues have potential to have endophytes. So if you have an endophyte, that is a good way to ward off chinch bugs. The big-eyed bug is an important predator, beneficial predator with them. And we also have a fungal pathogen called Bavaria bassiana that acts towards controlling these chinch bugs as well. But typically, if we're in a rescue situation, we're looking at Astro or Telstar. 7 can be used as well. And so we see a suppression of chinch bugs with acelepryn or Meridian. And so, Jennifer, I know we're up on time here, so just want to quickly mention crane flies. The larvae are known as leather jackets, and this is what we see with the adults will have these very long legs. So it reminds you of a mosquito with these giant legs here. But these are the adult crane fly. These are the juvenile crane fly. They look like a tan brown caterpillar with no legs, and the adults, like I said, look like giant mosquitoes. The adults emerge in summer, fly, mate, lay their eggs in the thatch, and then once the eggs hatch, the small brown larvae will feed in the fall, then over winter, and then in the spring the larvae will continue to feed, and then the early summer they'll pupate just below the soil surface. So I want to wrap it up with that. This is what the crane fly damage kind of looks like there. Damage, I will say, is more typically noticeable in the late fall and the spring, but this is pretty bad crane fly damage there. So a lot of our, something like a acelepryn or our safer product with the chlorantrin, Niloprol, can be used for crane fly control. This is not a huge pest, but it's one we see in certain pockets of the northern region of the country. And we've had issues with this on the Pacific Northwest for a number of years. So wanted to at least mention it. So again, I'll kind of wrap up there. There's my X, formerly Twitter handle there. So feel free to contact me, my email information as well. So feel free to contact me if you have any questions. And again, Jennifer, thank you so much for having me on the webinar today.
We definitely appreciate your time, Geoff. That was a very valuable presentation. And thank you to our attendees. We appreciate you being here as well. This recording will be available on the SFMA website later this month, and it will also be part of our educational library. So looks like all of our attendees have left. We won't be taking questions, but we appreciate everything, Geoff, and I hope you have a good rest of your day. Thank you.